Welcome to the debate. Today we are standing at what feels like the absolute precipice of a fundamental shift in how we manage the digital bedrock of our world. I mean, for 40 years, databases have been these silent workhorses, right? Passive containers just waiting for a command. If you didn't query them, they didn't speak. But that relationship is, well, it's about to change entirely. We're moving from the database as a tool to the database as an intelligent partner. We're discussing the new Oracle Agentic Mission Control Panel.
Or, as I might frame it, we're discussing whether we're truly ready to hand the keys to our most critical infrastructure over to a hallucinating chatbot.
I see we are wasting absolutely no time getting to the friction point today. To frame the discussion for our listeners, the central question concerns the introduction of agentic architecture into database management. Is this federation of agents a revolutionary leap that elevates human administrators to mission directors, or is it, as you seem to suggest, a dangerous layer of Rube Goldberg complexity that invites catastrophic failure?
Oh, it's the latter. It is absolutely the latter. And look, I promise to explain why, and not just with skepticism, but with the scars of experience. We're looking at a proposal to turn the database control plane, something that needs to be rock-solid, boring, and deterministic, into a complex web of AI agents that guess as solutions.
Well, I think that characterization misses the forest for the trees. I represent the perspective that this is a necessary evolution. The sheer volume of data, the velocity of transactions, the complexity has outpaced human ability to manage it reactively. The Oracle Agent TIC MCP isn't just a dashboard. It's a system capable of prediction and self-healing.
And I'm here to represent the reality of the battle-scarred DBA. I'm approaching this from the perspective of someone who has actually been woken up at 3 a.m. because a smart system did something stupid. My stance is that adding probabilistic AI, which is what large language models are, to critical infrastructure is a liability. We need determinism, not a federation of agents making educated guesses.
Okay, let's start with the vision then, because I think you might be romanticizing a past that was actually quite painful. The current state of databases is a reactive world. You mentioned the 3 a.m. pager. That is the definition of the old paradigm. Humans are chained to alerts, drowning in metrics, scrambling to fix problems after they've already impacted the business. The control plane has always been a witness, not a participant. Its effectiveness was completely limited by the expertise and, frankly, the sleep schedule of the human watching it.
I don't deny the pain of the pager. I've lived it. I've missed birthdays because of it. But at least when I woke up and looked at the logs, I knew the system hadn't tried to fix itself and made it worse. I knew that select meant select. There was no ambiguity. The database did exactly what it was told. If it broke, it was because I broke it, or the developers broke it. It wasn't because the database decided to get creative.
But that's where the Mission Control Panel, or MCP, changes the game. This isn't just a fancier graph or a better alert system. It's an active intelligence layer. And the core innovation here is agentic architecture. We aren't talking about one giant monolithic brain trying to do everything. It's a federation of specialists. You have 5 distinct autonomous agents, each with a specific job, working in concert.
A federation? That sounds lovely in a marketing brochure. It sounds like a bureaucracy in practice.
It's more than marketing. It's mimicking how a high-functioning human team works. So let's look at the roster. First, you have the librarian. This acts as the long-term memory historian, tracking years of schema changes, documentation, past incidents. It's essentially a RAG, retrieval augmented generation system for your operational history.
A historian is fine, provided it doesn't rewrite history. We know LLMs have a tendency to confabulate details.
Then you have the watcher. These are the eyes and ears. But unlike a standard monitoring tool that just waits for a threshold to be crossed, the watcher uses anomaly detection to forecast trends. Then, the tuner, a specialist in performance. The steward, which is critical, as it handles governance and compliance, the lawyer, in the room if you will. And finally, the orchestrator, the team lead that synthesizes all these inputs into a plan. This structure allows for predictive operations.
I see why you find that impressive. I do. On paper, it looks like a well-staffed department. But I come at it from a different way. This federation model violates the absolute core principle of database reliability. Simplicity. You're describing a system where 5 different AI entities have to communicate, agree, and then execute. To me, that's a Rube Goldberg complexity trap.
I'm not convinced by that line of reasoning because complexity is inherent in modern systems, whether we like it or not. I mean, we're already running microservices with thousands of endpoints. We're managing that complexity with specialized agents rather than burdening a single human brain.
But you aren't managing it. You're multiplying the points of failure. Instead of one reliable system, you've now introduced 5 new, distinct points of failure. If the librarian gets confused and retrieves the wrong context, the whole chain breaks. If the watcher hallucinates a spike that isn't there, the orchestrator acts on bad data. Look at the historical context. Remember the 2023 FAA outage?
I do, distinctly. But that was a legacy systems issue, wasn't it? A corrupted file in the NOTAM system?
It was a failure of redundancy. Even simple redundancy. Primary and backup failed there because bad logic corrupted both systems. The backup just synchronized the corruption from the primary. Now you want to take that risk and multiply it by 5 layers of probabilistic AI logic? That is exponential risk. We need deterministic automation. I need to know that if X happens, then Y happens. Not, well, if the librarian feels nostalgic and the watcher is in a good mood, maybe Z happens.
I think you're conflating probabilistic with random. These agents are grounded in the system's own data. They aren't writing poetry, they're analyzing SQL logs. Let's discuss the mechanics to see if we can bridge this gap. The source material describes a specific scenario. An e-commerce database gets hit with a massive, unexpected traffic surge. In your world, the site goes down and you get paged.
In my world, I have capacity planning and auto-scaling groups set up months in advance. But go on. Tell me how the agents save the day.
In the agentic world, the watcher didn't just alert on the spike. It quantified the problem and forecasted the trend. That is a key distinction. It projected the failure before it happened based on the rate of change. The orchestrator took that forecast and activated the team. The tuner immediately diagnosed the specific query, let's call it query 147, that was about to buckle under the load and proposed a tactical fix, a vector index.
Whoa, stop right there. A vector index on a production system under heavy load? That is incredibly risky. Building an index is resource-intensive. You could lock the table and cause the very outage you are trying to prevent. That's exactly the kind of smart decision that kills a system.
Exactly, and that is why the system didn't stop there. This is where the Federation shines. The librarian chimed in. It accessed the long-term history and recognized this exact pattern from last year's holiday surge. It recalled that the effective strategic fix wasn't an index, but scaling out with 2 read replicas to offload the analytics queries.
That is a compelling story. It really is. It sounds like a movie script. But I'm sorry, I just don't buy that it works that smoothly in reality. You're trusting the librarian to retrieve the correct context. What if it retrieves an outdated configuration from 2019? What if the watcher sees a pattern that isn't there? You're dealing with large language models. They are probabilistic engines. They predict the next token, the next word.
But they're predicting based on the specific telemetry of the database. It's a closed loop. The model isn't trained on the open internet for this. It's trained on database internals.
A guess is still a guess. A DBA needs exact facts. If I'm debugging a lock storm, I need the session ID. I need to know exactly who is blocking whom. I do not need a polite summary that might be true. If the librarian hallucinates a memory of a fix that actually caused a crash 3 years ago, and the orchestrator executes it, you've automated your own demise. You've built a machine that makes mistakes faster than a human ever could.
That's a fair concern regarding hallucinations, but that's precisely why the steward agent exists. We haven't talked enough about the steward. It didn't just let the tuner and librarian run wild. The steward verified that the proposed solution, the read replicas, complied with all security policies, budget constraints, and operational windows. It gave the all clear. It's a system of checks and balances.
Checks and balances work between humans because humans have judgment.
But if the steward is also an AI trained on the same fuzzy logic, it's just the blind leading the blind. The steward is just another model checking the homework of the first model. It doesn't have agency, it has programming. And if the prompt engineering on the steward has a loophole, it will approve a disaster. This brings me to the issue of speed. You view this rapid synthesis as a benefit. I view it as the speed of failure.
How can speed be a liability when you're trying to prevent an outage? The orchestrator synthesized inputs from the tuner, librarian, and steward and presented a plan in minutes. A human team would have spent hours digging through logs, arguing over the root cause, and looking up old documentation. That latency is what kills businesses.
Because speed kills if the decision is wrong. Let me give you a counterexample. Imagine the AI tuner notices a slight production lull. It decides, hey, this is a great time to rebuild this massive 10 terabyte index to improve efficiency. It calculates the cost, it looks at the charts, and it looks efficient. It starts the rebuild.
Okay, standard maintenance.
But suddenly, a real traffic spike hits, maybe a flash sale or a celebrity tweet. The table is locked because the rebuild isn't finished. The database stalls. The AI optimized for a local variable, efficiency, and destroyed the global variable, availability.
But the steward.
The steward might see that the rebuild is compliant with policy. It's allowed to rebuild indexes. It's within the budget, but it lacks business context. A human knows, don't touch this table during Black Friday week, or we have a marketing blast going out in 10 minutes. The AI only knows its training data. It doesn't know that the CEO is about to do a live demo.
That's an interesting point, though I would frame it differently. The goal isn't to remove the human entirely. The system presented the plan for approval. The human operator is still the final gatekeeper. The AI didn't execute the read replicas or the index rebuild on its own. It asked for permission. The system alerts the human. Here's the situation, here's the plan, approve.
Ah, yes. The mission director, the human in the loop, the ultimate fallback.
Yes, the mission director. This leads to our third point regarding the human role. In this new paradigm, the human is elevated. They're no longer the firefighter running around with a hose. They're the strategist. They set the high-level goals, they review the orchestrator's synthesized plan, and they give the final go. They're moving away from drowning in metrics to managing architecture.
Elevated is a nice word for removed from reality. This creates what I call the rubber stamp problem.
I'm not familiar with that term in this context. Is that like pencil whipping a checklist?
It's simple human psychology, also known as automation bias. Imagine you're that mission director. The system presents you with a plan. It says the watcher predicts a crash, the tuner suggests this fix, the librarian confirms we did it last year, and the steward guarantees it is safe. It's a 50-step technical plan involving shell scripts, SQL commands, infrastructure changes. Are you really going to audit all 50 steps in the 30 seconds you have before the crash?
Well, you would review the high-level logic. You check the strategy, not necessarily every line of syntax. You trust the tool to handle the syntax.
No, you won't. You will assume the machine is right because it sounds confident, it has fancy formatting, and you are under pressure. You will click approve. You are not a mission director. You are a rubber stamp. You cannot audit the AI's work in real time. If the AI is doing the thinking and you're just clicking the button, the human is no longer in the loop. They are a formality to absorb liability when things go wrong.
I think that's a rather cynical view of human capability and the interface design. The librarian makes the decisions explainable. It provides the context. It doesn't just say do X. It says do X because of Y, which we learned in Z. That transparency allows the human to actually trust the decision rather than blindly approving it. It essentially writes the incident report before the incident happens.
Transparency is great when you have time to read. During an incident, nobody reads the footnotes. We need systems that fail safely, not systems that explain why they're about to do something complex. This is why I advocate for delayed apply guardrails. Let the AI make suggestions, sure. Use the tuner to generate the script, but do not give it the keys to execute. Let a human review it on Monday morning, not during a live incident.
But by Monday morning, the outage has already happened. This is the crux of it. The reactive model simply cannot keep up with the scale of modern data.
If we stick to your delayed apply method, we are accepting downtime as a necessary evil. We're saying it's better to be down than to risk an AI fix. The agentic MCP offers a path to zero downtime through predictive healing. We can't let fear of the new prevent us from solving the problems of the present.
And I argue that complexity disguised as innovation is the fastest path to 100% downtime. If I run a script I wrote, I know what it does. If I run a plan generated by an orchestrator based on a hallucination from a librarian, I'm gambling with the company's data. I'm gambling with customer privacy.
I suppose that brings us to the fundamental disagreement. I see a federation of specialists that turns the database into a learning organism, capable of adapting at machine speed.
And I see a Rube Goldberg machine waiting to hallucinate a disaster. I see it loss of control. I see a future where we don't know why the database is running, only that the agents seem happy.
Let's wrap this up. We've covered the mechanics of the federation, the interplay between the watcher, tuner, librarian, and steward. We've debated the tension between the speed of action and the risk of the speed of failure, and we've looked at the shifting role of the human, from firefighter to mission director. From my perspective, the agentic MCP is the inevitable future. The database must become an intelligent partner. The ability of the librarian to remember history and the watcher to forecast problems solves the two biggest bottlenecks in operations: lack of context and lack of time. It's self-healing, explainable, and necessary.
Means deterministic automation, scripts that do exactly what they're told, every time. The Federation introduces probability into a binary world. The risk of hallucination, the danger of the rubber stamp approval, and the complexity of 5 interacting agents make this a critical failure waiting to happen. We need better tools, not smarter agents.
It seems we have reached an impasse, but a fascinating one. The tension between the desire for autonomous, self-healing systems and the need for absolute deterministic human control is clearly going to define the next decade of database administration.
On that, we can agree. Just don't ask me to approve the AI's plan without reading it first.
Fair enough. Thank you to our listeners for joining us on this deep dive into the future of Oracle and agentic AI.
Keep your scripts deterministic, everyone.
Until next time, this has been The Debate.